So we're on chapter 5, distributions, and things can vary a lot. If we use this idea of median here, so if you know just the median temperature, those look pretty similar, 72.5, 73.5. So you might think, well, maybe these cities are very close together. Maybe they're not. Here's the question. Is the median high temperature of each day higher in Memphis or Los Angeles? Now, if you follow weather, and this is something you do when you get older, you would think, well, Memphis is probably higher, maybe even a lot higher. You might think, well, let's look at it and see. So this is from, I think, weather.com. You can see this is, let's see, this is Memphis right here. So this is Memphis. And so in January, the median is 48, 53, goes all the way up to 91. That's no surprise. Thought it might even be higher, 90, and all the way down to 51 there. So it has a pretty big range of values there. Whereas if you've ever been to California or Los Angeles specifically, even in the wintertime, it's 68 is the median. 84 is the high. So not a lot of fluctuation. There's a lot more variation in this graph. A lot less over here. So the median really doesn't tell us that much about how the graph may fluctuate. There could be some drastic changes there. It doesn't tell us that much. The median is actually 72.5 for Memphis and 73.5 for Los Angeles. So that's a little bit surprising. The median temperature is actually a little bit warmer, even though it's kind of a milder temperature there, and it gets really hot in Memphis. Now, you can see the max is 91 compared to 84, 48 compared to 68. This is called a 5-number summary, min, max, Q1, and Q3. And we use that 5-number summary all the time, and you might remember we talked about the IQR. It's a formula. So the IQR is equal to the value of Q3 minus Q1. So it's a numeric value. It's not a range of values, it's a numeric value. This is what we're going to talk about a little bit here. So I'm going to bring this up just a little bit so you can see it. So if you look at the data here, let me move this Q1 and Q3 thing here. So this is a very handy graph. You can see, we can kind of see the 5-number summary is kind of hidden in this graph here, actually. So if you look at, say, the min of 48 is this value right here on the graph. It's 48. If you look down, it's right about 48. 57.5 is this value right about there. So that's an important value on the box plot. 72.5, the median is in the middle. That's that value right there. If you go down, that's 72.5. 86 is this value right here. If you go down there to the x-axis, and 91 is this value. So the 5-number summary is represented clearly here on the box plot. Same thing for Los Angeles. And so you can very quickly kind of see, okay, what's the max, what's the min, and everything in between here. And occasionally you'll have a graph, and this one doesn't do this, but sometimes it has like a whisker and kind of like a dot out here, like it's an unconnected dot. If you see an unconnected dot, that would be called an outlier. So just be aware that that can happen on some of these. You'll see a dot way out there, and it's not connected to there at all. And if it's not connected, it's part of the data, but it's just considered an outlier. So these are not outliers because they're connected with a whisker there. So sometimes we call this a box and whisker plot, or a box plot, more commonly probably. So it's a graphical display of the 5 numbers, and they're good. They're really good at this. This is the key. If you want to find out an outlier, draw a box plot and do it on your calculator. That would be the key there. Easiest way to find outliers is to graph it. Now we're going to do this by hand. So if we start with a data set, there's your data set, the steps there, and you have this worksheet, so just kind of follow along. Put the data in order. You can't find the median unless you put the data in order. It has to be in order there. Then you find the median. Notice that the median is the middle value. Whenever you have, by the way, there's another 9 here. I don't know what happened to that. There's 2 9s there. But you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. When there are 10 values, you find the very middle point, which is between those 2 numbers. And so you're going to average 5 and 7 to get 6. And so that's our median. Whenever you have an even number of values, you'll have to average 2 numbers to find your median. So then once we've kind of split that graph there, down the middle, there's 5 pieces of data on each side. Then I find the middle of that half, which would be 3. And the middle of this half would be 8. And those are Q1 and Q3. Again, the same thing applies. Since there's only 5 numbers there, I don't have to average 2 numbers. But you literally want to split it that way. We very rarely have to do that by hand, by the way. Okay, let's look at this. Mark the 5 number summary values on the plot line. So the next step is to get a, draw an axis, an x-axis there, and plot points for those 5 numbers for the 5 number summary: min, max, median, Q3, and Q1. So that's going to be the kind of the skeleton of our box plot there. Draw the box. So you want to draw the box. That's, remember, this is Q3 right here, and this is Q1 right here. That's the median, right? So the box goes around Q3 and Q1 there. We just draw it like that. This is kind of the weird step here, and we do need to check for outliers. So right now I can't tell if I connect this line or I connect this line or not. Maybe those 2 points are outliers. We don't know. So we do what's called an upper fence. So this is kind of telling us how unusual that value is, if it's really unusual. So you take Q3 plus 1.5 IQR. So IQR is Q3 minus Q1. In this case, it would be 8 minus 3. So IQR is 5. If you take Q3, which is this value, 8, and add 1.5 times IQR, that's 7.5. So 8 plus 7.5 is 15.5. 15.5 is right out here. I'm going to draw a dotted line. Since this max point is well within this fence, it does not stray out here. If it strayed out here, that point would be an outlier. Since it's here, that point's not an outlier. I can draw this box, or at least that whisker, out to that point. Now let's check the lower fence. Q1, which is this point, 3, minus 1.5 IQR. So 5 times 1.5 is 7.5. So 3 minus 7.5 is negative 4.5. That's right about here. This point is well within the fence, so I'm going to connect that min with the Q1. And now we have our box plot. So we don't have to draw these dotted lines, but they tell us how unusual those min and max points are. There could be numerous outliers, in fact, but usually the min and max would be the outliers if there are some. Finally, draw the whiskers. That's what we just did. Use a star if it's more than 3 IQRs away. So if it's 1.5 plus another 1.5, so it's way out there. Sometimes we'll use a star to say, instead of just like a point like that, well, here, point like that, we'll use a star to indicate it's way far out there. An asterisk will work just fine there. Oops. So this is an actual AP problem. It's a multiple choice. This might be the first one we've seen, an actual AP problem. Really scary. Not too bad. You gotta look at it. Sometimes you have to read all the answer choices. It's usually a good plan. So you read this about females and males. Spent time in a local store. They had data on each customer, right? So time spent in the store. So some people spend as much as 45 minutes in a store, whereas some people only spend 20 minutes there. So let's look at this and see if each statement, which is true. So the range is the amount of time in minutes males in the sample spend in the store is approximately 40 minutes. So males would be from here to here. It'd be this value, 45. minus the min, which is 5, which is about 40. That seems to be true. I'm gonna think that's true, but let's just keep going with this to make sure that we have everything right. Haven't looked at the rest. Not a bad idea to check. Sometimes we get fooled. The mean amount of time in minutes males in the sample spent in the store is approximately 20 minutes. The mean. We can't really see the mean from this. That's the median is 20. I don't know. In fact, it's not. It's a little skewed to the right. So I don't think that's also the mean. The mean would probably be somewhere in here. It's going to get pulled with a skew. So I don't think that's going to be a right answer. The third quartile is the amount of time in minutes. Males in the sample of customers spent in the store is approximately 45 minutes. Third quartile would be here. That's Q3. And that's about 29 or 28, not 45. I don't agree with that. Interquartile range is the amount of time in minutes. Females spent in the store is approximately 15 minutes. So the IQR for females, this would be about 17 minus 8. 17 minus 8 is about 9, not 15. I don't agree with that. Approximately half of the males in the sample spent at least twice as much, as much time in the store as any female. Approximately half the males spent at least as much time in the store as any female in the sample. Approximately half of the males, spend at least as much time in the store as any female in the sample of customers. Well, that one seems true too. So now I'm kind of stuck here. Now, I don't know if some of you are really observant or not, but if you were, you may have noticed that this is not the max for the males. In fact, there's a star right out here, there's a star right out there. This is actually the max for the guys. So when I wrote 45, that actually wasn't the max. That was just a non-outlier there. But the max is the largest value. So these are unconnected, so these are both outliers. And so this would have been 90 minus 5, which is not 40. So this one's not true. So you can see how tempting some of these wrong answers are. If you weren't paying attention there, you definitely would have just ignored the outlier there. And so you have to be really, really careful on this. Try this one. It's kind of an interesting problem. It'd be our last problem of the screencast. This is an interesting problem. So remember, you have to order the data. Well, the data is kind of ordered here, but we just don't know what the individual values are. There's 4 values between 0 and 2. So those are the first 4 numbers in the data set. There's another one, 5, 6, 7, 12, 13, 14, 15, 23, 25 values. There are 25 households. There's 25 values. So I want, if you kind of parse 25 out, I want between the 12th and the 13th value, 25. Will the 13th be in the middle? I think it would be, right? Because I would have 12 values to the right of that and 12 values to the left of that. So 13, I know it's an odd number, so I know there's the middle value is, the median is one number, not a combination or average of 2 numbers. So 13th, what is the 13th term of this data? So what you want to look at is, okay, well, clearly it's not in these first 4. So there's 4, 5, 6, 7. I'm going left to right, smallest to biggest. 7, 12. So that's the first 12 pieces of data are here. So the 13th piece of data has to be in this block. Or if I count from the right, 2, 10, 13. So it's got to be in this block. That's where the median is, which is weird because it's not the tallest, but the answer would be from 8 to 10. So the median of the data is located in this block because I counted 12 pieces there, 10 pieces there. The middle piece is the 13th piece. It's going to be right in there.